Hi everyone, so welcome to my lecture 3 of single linked list. So this is about how we reverse a linked list, right? So this lecture is about how we reverse a linked list. So this is single, so as we are discussing only for single, we'll discuss only for single here. Yeah, I know. So there are mainly two approaches. One is iterative and one is recursive. So although you see in the coding session, so you may see in the code which I have pushed the recursive one. I'm not going to discuss about recursive here because before going through recursion we need to know like the recursive basics, like how recursion works and how we can proceed with the recursion. So for now we'll be only discussing about the iterative approach of reversing a linked list. So this will be a little bit complex, like changing of pointers. This can be a little bit like confusing, so I'll try to explain in a more simpler way. Okay, so to solve a big problem, first we need to take smaller part of it, right? So initially, let's say this is a linked list, right? Okay, this is a second node and this is a third node and this is a fourth node, right? Okay, so here the pointer will be pointing to head here and here it will be pointing to tail. Okay, so now these will be pointing like this. So what is our main goal? Our main goal is to reverse all these pointers. That means we need to reverse this, we need to reverse this, we need to reverse this, and then the tail will become head here and vice versa, head will become tail here, right? This is our main goal. So we need to convert this particular linked list and we need to reverse all the pointers. So before that, first let's take a small part of this linked list so that we can have the understanding on how we are proceeding with the reverse, right? So let's say I'll place a previous pointer here. Okay, so let's say there is a previous pointer here and there is a current pointer here. Okay, right. See, the variable naming conventions in Go are different, so it will be camel case. So just to show the separation, as you know, my handwriting is too small, you'll confuse, like I'll merge those letters. So instead I'm keeping an underscore, but the naming convention doesn't seem the same way. Okay, so let me keep the current pointer here. Okay, so let's see. So now first what is my thing? I need to point this particular link to the previous pointer, right? That's what I need to do. So let me point it, current pointer dot next, I will point it to previous pointer. Okay, right. But now if you point current pointer dot next to the previous pointer, then you are losing this entire node, right? So you are going track of it, so you don't have a track of it. So before moving, like before pointing it, you somewhere you store something like next pointer or a future pointer. It's your wish, you can keep any naming convention, and you can keep this equals to current pointer dot next. So now you have a record, right? That's it. You point to this particular node and now you have pointed to this previous pointer. Okay, right? So now let's say you move this current pointer ahead, right? So that means your current pointer will become PTR, right? But before that, don't you realize that we need to move this pointer to forward also? Like we have done the task, we have solved this problem. We have made the current pointer dot next to the previous pointer, and now previous pointer should go forward, right? Okay, yeah. See, like if you see the first node, it seems simpler, right? Why don't you make previous pointer dot next, right? So why can't you make this previous pointer point to directly previous pointer dot next? You can simply do this, right? You can ask the same question to me, but that's not the case, because this current node, like the previous pointer, has already been pointed to its previous node. So right, if there is a node here, then that this particular thing is already pointed to the previous value. Okay, so instead of going that way, we can simply make our previous pointer to our current pointer, right? That's simple. That is simple. And now next the current point. See, after completion of entire task here, you need to move your current pointer also, right? So now my current pointer will move to next pointer, right? That's simple, right? So now this is closed and we are moving to here, current pointer, and now this will become your previous pointer. In the same way, you'll hop everywhere until your current pointer is not equals to nil, right? Is not equals to nil. And whenever you reach the end of the single linked list, so that means your previous pointer is pointing to this value, right? The last node, right? So you now where is your so let me keep it clear. So now where is the head pointing to? Here. And where is the tail pointing to? Here, right? So now what I can make is SLL dot tail will become your SLL dot head. And what is your SLL dot head? SLL dot head will be simply your previous pointer, right? I think you get this reversing of a linked list. Yeah, it may look complex at the single like it for the first time, but when you keep on doing with some examples, like try to do with 3 nodes, try to do with 2 nodes, try to do with 5 nodes, then you'll get a clarity, like why I'm taking this approach directly. Yeah, it takes some time, like it took me the same, because I was also learning in parallel while I was telling you. So this is the easiest way which I got to know, like make it simpler, like break it into sub problems, like make it for the 1 node, solve it for the 2 nodes, solve it for the 3 nodes, solve it for the 4th node. Then you'll understand the pattern. So the key thing is, in the linked list, if you want to solve problems, you need to know the pattern. If you know the pattern, no, then it's easier to solve the problems. Yeah, I think you get it. So let's jump into VS Code session. Let's see how we can implement a reversing of a linked list in Go. So first we'll have a previous pointer which is automatically pointed to nil, and you can keep current pointer to head, and you should loop until the current pointer is not equals to null, and which I discussed previously. So you should keep a next pointer which will point to the current pointer dot next, and your current pointer you'll move to the, like you'll point it to the previous pointer, and you'll move the previous pointer, and you'll move the current pointer. After end of this loop, you can simply point your tail to the head, and your head will be the previous pointer, right? So in this way you can code it in Go. Yeah, I hope you are liking my videos, so make sure to like and subscribe, and if you have any doubts, please feel free to comment below this video, or you can simply comment on the blog which I post all this code there. Okay, so let's meet in another session. Until then, bye bye.